This is a problem from this year's USAJML. Let ABCD be a cyclic quadrilateral with AB equals 7 and CD equals 8. Points P and Q are selected on segment AB such that AP equals BQ equals 3. Points R and S are selected on segment CD such that CR equals DS equals 2. Prove that PQRS is a cyclic quadrilateral. So first I'll name the circumcircle of ABCD. Let's name that M. And then I'll label the center of the circle as O. Next I'll label the lengths. So AP equals 3, BQ equals 3, and since AB equals 7, PQ equals 1. CR equals 2, DS equals 2, and because CD equals 8, RS equals 4. Now I'm going to find the power of these points, PQ, RS, in respect to circle M. So the power of P with respect to circle M equals negative AP times BP. And then the power of Q with respect to circle M is negative QA times BQ. The power of R with respect to circle M is negative CR times DR, and the power of S with respect to circle M is negative CS times DS. So let's calculate all of these. Negative AP times BP. AP is 3, BP is 4. Negative AP times BP is negative 3 times 4, which is negative 12. QA equals 4. BQ equals 3. Negative 4 times 3. That equals negative 12. Negative CR times DR equals negative 6 times 2, which is negative 12 again. And the power of S with respect to circle M, negative CS is negative 6 times DS is 2, so that equals negative 12 as well. So since all of these points PQRS have the same power with respect to circle M, that means that they're all the same distance away from the center of the circle. So they're all the same distance away. And if they're all the same distance away, you can draw a circle. You can draw a circle with all 4 points in it. So that proves that PQRS is a cyclic quadrilateral. The fact that all 4 of the powers of the points with respect to circle M is negative 12.